So this second video focuses on determining geometry and shapes when you are given a molecule. So for example, here we are given a molecule, methane. We want to determine the geometry and shape of this molecule. So actually there are rules that you need to know to determine the geometry and shape of a molecule like methane. So the first rule, rule 1, add all the valence or outer shell electrons. So in this case, of all atoms present in the molecule. So in this case, we have carbon and we have 4 hydrogen. So each carbon has outer electrons. Each carbon has 4 outer electrons. That's why it is in group 4. And each hydrogen has 1 outer electron, but there are 4 of them. So 4 times 1. Now if you add these, you are going to have 4 plus 4, which is 8. So this molecule has 8 valence electrons. So that's the first rule. Add all the valence or outer shell electrons of all atoms present in the molecule. So we see that a methane has 8 valence electrons. Now, once you do that, the second part is rule number 2. Find the central atom. So one thing is that hydrogen H is never a central atom because it forms only one chemical bond. So an atom needs to form more than one chemical bond to become a central atom. So hydrogen is never a central atom. So in this case, it's easy. Our central atom is carbon. So our central atom is carbon. So that is rule 2. Rule number 3. Connect side atoms to central atom. By single bonds using single chemical bonds. So in this case, we are going to have carbon here, and then hydrogen, 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 hydrogen. So connect side atoms to central atom using single chemical bonds. Rule 4, give 8 electrons to each side atom except hydrogen, which must be given 2 electrons. So in this case, the first 2 electrons you give should be between the central atom and the side atom. So the first 2 electrons must be between central and side atom. So that's the rule number 4. You give 8 electrons to each side atom except hydrogen, which must be given 2 electrons. So the issue is hydrogen is in shell number 1. And we know that shell number 1 has only s orbital, which is filled up by 2 electrons. That's why you give hydrogen only 2 electrons, because hydrogen does not need an octet, does not fulfill an octet. It fulfills its octet using 2 electrons. That's why you give 2 electrons to hydrogen. But even if you are giving 8 electrons to the side atom, the first 2 electrons should be between the central atom and the side atom, because those first 2 electrons are the ones that are forming the chemical bond. So if I have to get rid of this, so here we are saying we are giving 2 atoms, and the first one should be between the central atom and the side atom. We are giving 2 electrons here. So these are the 2 electrons that we are giving. So each chemical bond is actually 2 electrons. So each side atom, which in this case is hydrogen, must be given 2 electrons. So if you see a single stick is 2 electrons. So which means these 2 electrons I have written here are not needed, because the stick itself is 2 electrons. So I'll say that in this case, the hydrogen has already been given its 2 electrons. So I'll say each stick of hydrogen and carbon has 2 electrons. So this is fine. Rule number 5. After you have given the side atoms 8 electrons or 2 electrons in the case of hydrogen, count how many electrons are remaining. How many valence electrons are remaining? So you give the remaining electrons to the central atom. That's what you do. But for our molecule, we said that CH4 has 8 valence electrons. Now, if we give hydrogen 2 electrons, it will be 2, 4, 6, 8. So it means we have used up all the electrons here. There are no electrons remaining. So in this case, no electrons are remaining. All of them are used up. So we can say no electrons are remaining, which means now we no longer want to give electrons to anything because we have used up all the electrons. Now we can think about this molecule. What is its shape? If we take each stick as 2 electrons, this molecule is surrounded by 4 sticks, which means it has 4 pairs of electrons. So if I want, I can write it as carbon here, 1 pair of electrons, the second pair of electrons, the third pair of electrons here, and the fourth pair of electrons. And we know the geometry when you have 4 pairs of electrons is tetrahedral. So this is 4 pairs of electrons. So the geometry is tetrahedral. And the shape is also tetrahedral because we have 4 chemical bonds here and no non-bonding pair. So we have 4 chemical bonds, no non-bonding pair. So the shape is also tetrahedral. Now let's go to this. Ammonia. We follow the same rules. So rule 1, add all the valence electrons. So nitrogen has it's in group 5, so has 5 valence electrons. Hydrogen, each hydrogen has 1 valence electrons, 1 valence electron, but we have 4 hydrogens. I mean, we have 3 hydrogens, which means the hydrogen in there, the 3 of them will add 3 valence electrons. So if you add all the valence electron, we'll have 5 from nitrogen, 3 times 1 from hydrogen, to give us also 8 valence electrons. So ammonia also has 8 valence electrons. Now we are going to work with that. So the second rule is find the central atom. This one is easy. The central atom is N because we have a smaller number. And also because hydrogen can never be a central atom. Rule 3, connect side atoms to the central atom. So I'll take nitrogen and then connect side atoms there. Rule 4, give 8 electrons to the side atoms, or 2 electrons in the case of hydrogen. So give 2 electrons to each hydrogen. But we know that the first 2 electrons should connect between the central atom and the side atom. So each stick there is 2 electrons. So which means electrons used, we have used 6 electrons. Electrons remaining, we are remaining with 2 electrons. Now the rule says take the remaining electrons and give to central atom. So we just take the 2 remaining electrons and put them here. So first we find the central atom. The central atom is nitrogen. Or first we add valence electrons. We find that we have 8 valence electrons. Then we determine the central atom, and the central atom is nitrogen. We give 2 electrons to each side atom, which in this case is hydrogen. And then we count how many electrons have been used. So we used 6 electrons to form chemical bond. And how many electrons remained from 8? 2 electrons. And then you give those remaining electrons to the central atom. So eventually, you can say that your geometry is tetrahedral. Your geometry is tetrahedral because we have 4 electrons or 4 electron groups surrounding the central atom. So geometry is tetrahedral. So 4 groups of electrons surrounding central atom. Now shape is trigonal pyramidal. because here we have formed only 3 chemical bonds. So 3 chemical bonds and 1 non-bonding. So we have 3 chemical bonds, 1, 2, 3, and then we have 1 non-bonding. So the shape and geometry will be different because we are lacking 1 chemical bond there. What about water? We do the same thing. Add all the valence electrons. So hydrogen, we have oxygen and 2 hydrogens. Oxygen has 6 valence electrons. Each hydrogen has 1 valence electron, and 2 of them will give us 2 valence electrons. If you add the 2, they'll give us 8 valence electrons. Now find the central atom. Here it's obvious, central atom is oxygen because there are fewer oxygen atoms there than the hydrogen. Then connect side atoms to central atom. So I'll take hydrogen or oxygen, which is the central atom, and then connect hydrogens to the central atom. Then give 2 electrons to each hydrogen. So each stick here is 2 electrons. So what we are saying is we have used, so electrons used is equal to 4. Electrons remaining is also equal to 4. So give 4 electrons to the central atom. So I'll take the 4 electrons here and put them here. So in the end, geometry will be tetrahedral because we have 4 electron groups, 1, 2, 3, 4. But shape will be bent because we have 2 chemical bonds and 2 non-bonding groups. So what we are saying is we are going to have something like this, all bent like this, and then the 4 electrons up there, or 2 pairs up there. Now we have this molecule here. We use the same rules. Count valence electrons. Here we have carbon, we have oxygen, and we have 2 chlorine. Carbon has 4 valence electrons, oxygen has 6 valence electrons, each chlorine has 7 valence electrons. So chlorine has 7 electrons, or 7 valence electrons. Now if we add them, 4 plus 6 plus 14. This gives us 24 valence 24 valence electrons. Now, once we do that, determine central atom. Now, in this case, we cannot use the fact that we have fewer atoms to make a central atom, because we have one carbon here, we have one oxygen. So both of them are 1, 1. So we have to select the central atom between carbon and oxygen. So which one do we select? Usually, the central atom is the one that is further left, lower side of the periodic table. So if we take carbon and oxygen, carbon is left of oxygen on the periodic table. So carbon is left of oxygen on the periodic table. So it will be our central carbon or our central atom. So carbon will be our central atom because it is left of oxygen on the periodic table. So what we are going to do is we are going to put carbon in the middle here as our central atom, and then put one chlorine here, another chlorine here, and then an oxygen there. Let me get rid of this part so that I have space. So we are going to have an oxygen here. So the second part is give 8 electrons. Give 8 electrons to central or to side atoms. So give 8 electrons to side atoms. So, but the first 2 should be between the central and the side atom. So I'll say each stick is 2 electrons. So we already have 2 electrons here, 2 electrons here, 2 electrons here. Now, which means I need 6 more electrons. So I'll give 2, 4, 6. And each stick is 2 electrons. So we have 2, 4, 6, 8 for this chlorine. 2, 4, 6, 8 for this chlorine. For this oxygen, we have 2, 4, 6, 8. So each one of the side atoms has 8 electrons. So the question is, should we be happy with what we have here? The answer is no. We shouldn't be happy. So what do we do? Or why shouldn't we be happy? We shouldn't be happy because the central atom, central carbon, has only 6 electrons surrounding it. That's not good. So we say each stick is 2 electrons. So carbon here has 3 sticks, which means it has only 6 electrons surrounding it. But we want 8 electrons to surround it. So what we do is this oxygen here, the oxygen that we have here, has more than expected number of electrons. We know that oxygen must have 6 electrons in its outer shell. But this oxygen here looks like it has more than its share of electrons. It has 8 electrons. So this will not make sense. Or if we get rid of the if we assume that oxygen in a chemical bond, oxygen is just offering one of the electrons, and the other electron is being offered by carbon. So if we just take one electron for oxygen in this chemical bond, we'll see that oxygen has 1, 2, 3, 4, 5, 6, and 7 if we take one from this chemical bond. So within this chemical bond, oxygen has an extra electron, which is not good. While oxygen has an extra electron, carbon is lacking electrons. So what we do is we take these 2 electrons here and put them on this to form another chemical bond. So in the end, what you have is you have carbon here with 2 chemical bonds bonded to oxygen, here chlorine, here chlorine. And we are saying that this one, 2, has 8 electrons, 8 electrons here. So if we get rid of 2 electrons and put them on a chemical bond, we are going to remain with 2 non-bonding electrons on oxygen. But still, it has 8 electrons because 2, 4, this bond, 6, this bond, 8. So every atom in this molecule has 8 electrons. So we are good with this one. Now the last part is, what is the geometry and what is the shape? So the geometry for this is trigonal planar because we have three groups surrounding the central atom. The shape is also trigonal planar because we have three groups of chemical bonds. You know that a double bond is taken as a single bond when determining the shape of molecules. So this would be like one bond, two, three. So the shape and geometry will be trigonal planar. So if you are given a molecule like this one, you need to know that it has two central atoms. So the first central atom is carbon, the second central atom is oxygen. And then this carbon is surrounded by three hydrogens, and this is connected to one hydrogen. So this would be like water. Geometry, tetrahedral. Shape, bent. This one, geometry and shape, tetra. I just said tetrahedral. So just go over this and answer the questions on the video assignment. Thank you.